try that.
Now to do the first two parts of the lab,
Ready?
what we have is we have this set up where you have a weight hanging on here. You also might have weight that you put on the cart. Now if you look on your data sheet, there's MH, which is the hanging mass, all right? And M star, which is the mass of the cart plus any additional weight we add onto the cart, okay? Now look at the definitions very carefully before proceeding. They're all up at the top of the data sheet as to what each thing is. The biggest mistake most people make is they screw up, you know, what the hanging mass is and what the additional mass in the cart is. What are you doing? She's holding the cart. What? Now, let's just do an experiment here, a physics experiment. Let go of the cart. Go ahead. That was a bad thing, wasn't it? Because it crashed up against here. Usually it falls on the floor. But that's okay. That's okay. Don't worry about it. So number one, what you need to do here is you see these things here? Put it like this to keep it from hitting the pulley. All right? Now you want to make sure that the pulley is high enough. Here, grab that, would you please? Here. Thank you. So that when you... Oh, by the way, don't forget the mass hanger mass too. People forget that all the time. You want to make sure that the pulley is high enough so that the string doesn't hit the top of the guard. Okay? Even so, with the number of people we have in the lab, someone should be keeping the cart from hitting the guard. It also just makes less noise and makes less of a mess. So go ahead. We'll demonstrate this. Go ahead, let go. Good enough. Someone should have hit collect data on the Logger Pro and gotten data from that. And that's where you make all your measurements. All right? Thank you, Lydia. You can sit down. All right. Now, for the third and fourth part, it's a little bit different. And we've modified it a bit from the way we used to do this lab. Now, what we do here is we put the force probe, and this is why it's very important in this part to make sure that you have someone holding it, because we don't want these to fall on the floor. The force probes themselves fit pretty nicely right on top of the cart. So we can measure that the force it takes to drag it, if we connect this up, which I'm not going to do there. You can measure the force that it takes to drag the thing if you tie a string. If you tie the string to the hook instead of the cart, and you pull on it. Okay? Now, on that part, you're just going to measure the acceleration directly and the force directly. This is 4A Newton 2B. After you calibrate the force probe, you can measure the force and acceleration, divide the force by the acceleration, and you get the total mass of this. That would be M star. Then you subtract off the mass of the force probe, and you figure out what the mass of the cart is. Then you compare it to the actual mass that you measured. Okay? Easy enough? Remember, you got to attach the string to the hook, not to the cart anymore. Now, for the last part, it's really simple. Parts 3 and 4 are really pretty simple. Parts 1 and 2 are the ones that kill people. We're going to go back to using the thing on there, but there's going to be a screw here that you can use to... This isn't the correct cart, it turns out. That's all right. There's a screw that you can use to adjust the friction. You can make it so it doesn't slide nice and smooth, but instead it drags. And what you want to do is you do the same thing. You measure the force that it takes to drag it, and you'll see that there's a little peak. It goes up like this. Up, and then... Actually, let me draw that on the board. If you're looking at the force, it's going to go up like that and then like this. Okay? Now what we have is a static force. This is force. The force it takes to get it to move. And you can read that directly off the Logger Pro. And then you take the average of this section right here, and that's the kinetic force.
That's right.
Okay? Now to get a coefficient of friction, you divide the force by the weight, in this case, because we're doing it flat. So it's the force that, in this case, like say if we wanted mu s, we take Fs and divide it by mg. Easy enough. If we want mu k, we just change these letters to k's. Where this is Fk, the average of this. this area right here. And this is FS. Okay, so that's part 4. Thank you very much. Cut.